Predictive Analysis Part 2. In this video, we will learn about random forest and extremely random forest. Now, what are random forests? A random forest is a particular instance of ensemble learning where individual models are constructed using decision trees. Now, what are decision trees that we have learned in our previous tutorial? So, we are constructing our random forest using those decision trees. This ensemble of decision trees is then used to predict the output value. We use a random subset of training data to construct each decision tree. This will ensure diversity among various decision trees. During the construction of the tree, the nodes are split successively and the best thresholds are chosen to reduce the entropy at each level. Next is extremely random forests. Extremely random forests take randomness to the next level. Along with taking a random subset of features, the thresholds are chosen at random too. So in this case, we are choosing thresholds randomly, and that's why our randomness will increase here. This randomly generated thresholds are chosen as the splitting rules, which reduce the variance of the model even further. Hence, the decision boundaries obtained using these forests tend to be more smoother than the ones obtained using random forests. So this is the basic difference between random forest and extremely random forest, that extremely random forests have more smooth boundaries than random forests.
Okay, let's see the program to create random forest. First, we are importing few packages. These are NumPy, Matplotlib for plotting purpose, and sklearn. Sklearn is your scikit-learn package, which is more important package here. Utilities is your class, which we have seen in our previous tutorial, and visualize classifier is your function defined in that class. So now here we are using arguments. So we are using argument parser for parsing arguments, because we are passing arguments on the console for executing that program. So first we have defined a function build arg parser. So in that we are using argument parser function, and we are adding our argument classifier type. So our classifier type can be either RF or it can be either ERF. So RF is representing your random forest and ERF is representing your extremely random forest. So whatever we want to plot, we will pass that argument according to our choice. Next is your main function. So here we will parse our arguments and take these arguments in our variable classifier type. So either it will be RF or it will be ERF. So this line is nothing, just comment it. Next, we are loading our input data. So data random forest.txt is your file, and we are using load.txt function of numpy package to load the data in data variable. Next, we are applying slicing operation on data variable for getting data into x and y variable. Now y is a variable which is containing either 0, 1 or 2. So we are using it as an index for getting data from data variable, and we are separating our input data into 3 classes based on labels. So based on these labels. So these classes are class 0, class 1 and class 2. Next step is to visualize our input data. So here we are using scatter function of pyplot package, which is defined in matplotlib package. So this scatter function is taking arguments. Here we are using marker equal to S for class 0, marker equal to O for class 1, and marker equal to this sign for class 2. And we are using title as input data. So and S is representing your shape, and face colors you know very well. Then next is we are splitting our data into training and testing data sets. So we are using cross validation package and the function train test split for splitting our data. Here we are passing random state equal to 5, which is representing your random data generator, and test size is 0.25, which is showing proportion of the testing samples, and x and y is our data. Next, we are defining the parameters to be used when we construct the classifier. So these are our parameters: n estimators, max depth, and random state. So what are these? The n estimators parameter refers to the number of trees that will be constructed. The max depth parameter refers to the maximum number of levels in each tree. The random state parameter refers to the seed value of the random number generator needed to initialize the random forest classifier algorithm. Next, we are passing arguments, right? So if it is RF, if our classifier type is RF, then we will use random forest classifier function, and if it is ERF, then we will using the extract trees classifier function. So this function is a meta estimator that fits a number of decision tree classifiers on various subsamples of the dataset and use averaging to improve the predictive accuracy and control overfitting, which is the main functionality of random forest. It is controlling overfitting. Similarly, extra trees classifier is for generating your extremely random forest, and this is for random forest. So next you are visualizing your training and testing data set. So say we will use our visualize classifier function, which is defined in utilities class that you know. Next we are generating our classification report. So we will same use our classification report function and passing 4 arguments. So by using this function we are evaluating our classifier performance. Okay, next is your new step. We are computing confidence level here. So first we are taking a random data points. These are 5, 5, 3, 6 like this. We are taking 6 data points in an array, and then we are finding our confidence measure. So what we are doing, first we are calculating probabilities. So we are using predict prob a function and passing our data point array in that function, and then we are getting maximum probability. We are using maximum probability for getting our predicted class. So here this is your data point and predicted class. So for each data point it compute the probability of that point belonging to our 3 classes. That point can be related to any of the class, so we will pick the one with the highest confidence. Okay, next is we are visualizing our data points. So again we are using visualize classifier function, and we are giving it as title test data points, and we are passing classifier and our test data points because we want to visualize these points. And next we are using show function of pyplot package. Now after running that program, what will be the output? Let's see. Here is the output. So first, this is your input data. Here there are 3 type of markers: square, triangle and circle, that you know, that class 0, class 1 and class 2. Next, this is your training data set and this is your test data set. We are using here RF as a argument. So that's why here this is random forest for the training data set and this is random forest for test data set. And this is your classification report. So this is your classification report on training dataset and this is your classification report on test dataset. So these are your 4 columns: precision, recall, F1 score and support. Next, this is your confidence measure. So here these are the 6 data points and predicted class for each data point. And last is your plot of test data points, that is plot of data points. So these are your 1, 2, 3, 4, 5, 6 data points, and these 3 are representing your 3 different classes. So class 0 2 points, class 1 2 points and class 2 2 points. So in each class there are 2 points plotted. See, so this is your plot for the data points. Now see here the boundaries. These boundaries are not smooth, but if we are passing ERF as argument, then these boundaries will be smooth. So one more thing I have to show you, that for running that program, what you have to write, I'm just writing here. Python, your file name, here my file name is randomforest.py, then your argument. So argument will be classifier type, and then you will pass either RF or ERF. So for running you will type this line. Okay, now let's see. If you are using argument as ERF, then your plot will be like this. This is your training and test data set. Now see the boundaries here. So these boundaries are more smoother than the previous one. This is your extremely random forest, and that was your random forest. So here boundaries are not much smoother than that. Also compare your data points plot. This is your data points, test data points, which we have used. These are 6 data points and predicted class for them. So in that plot, see the boundaries. These are your 6 points, data points, and now compare it with that plot. So here boundaries are not much smoother. This is the case of random forest, and this is the case of extremely random forest. One more thing is that for running that program you have to write statement, that is Python, your file name, and then argument. We have used hyphen classifier type and ERF. Here you can write RF or ERF as your argument. If you are writing RF, then random forest will be plotted, and if you are using ERF, then extremely random forest will be plotted. So here hyphen classifier type, why we have used that variable? So just see that here in add argument function we are passing this classifier type. You can use any variable here and you can run that program. So that's it.